Okay. Hi everyone. How are you today? Excuse me, online student. Can you hear me?
Yep,
Can you hear me? Yeah, thank you. So last week in tutorial class we start with fluid mechanic properties. Okay. And last week we worked with some main properties like vapor pressure, density, lapse rate. Okay. So this week we will continue with other property like viscosity, surface tension coefficient, and stress. Let me see, and surface and viscosity, surface tension coefficient, and Buck modulus of elasticity. Okay. We still have some properties we have to finish today before coming to the next topic is pressure variation. Okay. Firstly, do you have any question about tutorial last week or lecture? Do you have any question for me before we coming to some question today? No? Okay. So this one is what we did last week. Okay, this one is question 2. This one is question 2 in tutorial 1. And last week we finished some question 1, 2, some question about density, vapor pressure, lapse rate, boiling temperature. Okay, so this week we still have some question like you have to find surface tension coefficient, Buck modulus of elasticity. Okay, we will go very quickly because this one you with this question you only use the table. You have the values of viscosity of surface tension coefficient and Buck modulus of elasticity. Okay, so we will start with the first one today. You have to find viscosity of water at 5, 20, and 50 Celsius. Okay, and to find this one, you have to use the cost note. The cost note you can download on UTS online. Okay, and this one I open it. This one the cost note. Okay, and in the cost note you have table. And in this question 3, the small question 3 in question 2 tutorial 1, you find viscosity of water at 5, 20, and 50 Celsius. Okay, so to answer this question, you use this table, physical properties of water, SI units. Okay, at 5, 20, and 50 Celsius. So you have viscosity, yeah, in this column. At 5, viscosity is 1.518 times 10 minus 3. Okay, because you see viscosity times 10 power 3 equals to 1.518. So viscosity in this case will be equal to 1.518 times 10 minus 3. Okay, it's similar for 20 and 50. You use table. Okay, it's very easy. Use table. You have you can answer the question. Okay, viscosity of water at 5, 20, and 50 Celsius. And after that is surface tension coefficient of water at 5 and 60 Celsius. Okay, surface tension coefficient. You use the same table. Surface tension coefficient, gamma here. The unit is Newton per meter. Okay, at 5 and 60. At 5, you have is 0.0749, and 60 you have here. Use table. Nothing to say about this question. Okay, use table, you have the answer. Properties of water, you have physical property of water table, this table. Okay, use this table, you can find all properties of water based on temperature. Okay, so this one viscosity of water at 520-50 and surface tension coefficient of water at 560. That's easy. Bulk modulus of elasticity of water at 20 Celsius. Use the same table because bulk modulus of elasticity E is a properties of water. So properties of water, you use physical properties of water table. Okay. But this one is modulus of elasticity E times 10 minus 6 at 6, let me see, at 20 Celsius. So at 20 Celsius, E times 10 minus 6 will be equal to 2.17. Okay. So E in this case will be equal to 2.17 times 10 power 6. Okay. So be careful. And the unit here is kilopascal, kPa. Okay. So in the calculation, you have to convert this one to Pascal. Okay. So in this case, at 20 Celsius, the E will be equal to 2.17 times 10 power 12 Pascal. Okay. Got it? This one, we have 3 questions. Only use table, you have the answer. Then pressure required to reduce volume. Okay. After that, you find the pressure required to reduce the volume of water by 1%. Here you have. Actually, Fluid Mechanics Summer group chats on Facebook. Actually, you have to ask a friend. Maybe the friend will create some group on Facebook or on Teams or anywhere. Okay. Okay, so here you have to find pressure required to reduce volume of water by 1%. How to find this one? In this question, you have bulk modulus of elasticity E. Okay, E, you have E at 20 Celsius is use table. You have here, this one will be is 2.17. Okay, you have is 2.17, 10 power 12 Pascal. Okay, power 6 kilopascal. Sorry, so not power 12, power 9, sorry. This one is power 9 Pascal. Okay, kilopascal. You convert from kilopascal to Pascal. And in this question, you have to find the pressure required to reduce the volume of water by 1%. Okay, and how to find pressure required to reduce volume 1%? Do you remember equation to find elasticity? Elasticity E, you have equation in the lecture slide. E equal to show you the relationship between pressure change and the volume change minus delta P over delta V divided by V. This one equation to find elasticity. Okay. It's minus delta P divided by delta V, or V is elasticity. And the volume, you see, you have to find that pressure change, pressure required to reduce the volume of water by 1%. Reduce 1%. Reduce 1%. It means you have delta V over V will be equal to minus 1%. Okay. We have the negative because this one is reduced, because the volume of the state 2 will be smaller than the volume of state 1. Okay. So to reduce the volume is 1%, it means delta V over V is minus 1%. Okay. So from this one, you will have E equal to minus delta P over minus 1%. or you will have delta P equal to 1% of E, 1% of E. This one will be equal to 2.17 10 power 7 Pascal. Okay, or 21.7 megapascal. Megapascal. This one is very high pressure. This one is very high pressure. This one is megapascal. Okay, megapascal. Hi. Fluid mechanic. Fluid mechanic. Yeah, please come in. Yes, please come in. We start already. Yeah. Yeah, and others online. We run parallels online and face to face. Yes, all right. Yeah. Yeah, I'm running online. Okay, take a seat. Okay, so it means in this case to reduce the volume of water 1%, you need a pressure is 21.7 megapascal. It's very high pressure. This one because the water is incompressible substance. Incompressible substance is very hard to compress this. It's very hard to reduce the volume of water in this case. Okay, so you need this one, 21.7 megapascal. Okay, to reduce just only 1% of water. Okay. Do you have any question? No? Okay. So, okay, yeah, let me see. Okay, we finished bulk modulus of elasticity already. Kinematic viscosity. Okay, this one, as I said in the lecture yesterday, we have two kinds of viscosity: is dynamic viscosity and kinematic viscosity. So this kinematic viscosity is one properties of water. Okay, so for properties of water, you can use a table. This one. Okay, so in this table, this one is viscosity or dynamic viscosity. Okay, and kinematic viscosity here. So the question asks you for kinematic viscosity of air and water at 20 Celsius. Okay, so this one at 20 Celsius, water at 20 Celsius, you have here. The kinematic viscosity of water at 20 Celsius is 1.003 times 10 minus 6, because you see nu times 10 power 6 equals to 1.003. Okay, so kinematic viscosity will be equal to 1.003 times 10 minus 6. Okay, this one is for water. For air, okay, you have kinematic viscosity of air here. Okay. So we finish this question. Kinematic. Okay. Do you have any question about fluid magnetic properties, viscosity, surface tension, coefficient, and bulk modulus of elasticity? Do you have a question? Okay. And actually, the recording of the online class I upload on UTS Online. Okay. Yeah, we after this class, the recording will be uploaded on UTS Online. Okay. Yeah, the lecture online as well. Okay. In here. Okay. And I show you where to find the recording. Okay. Yeah, it's fluid mechanics. Sorry?
Is it a final exam or a time?
A final exam.
Final exam.
Yeah.
Online?
Online. Quiz and final exam online. Yeah. Yeah, you can find the recording in learning material and Zoom recording. Yeah. Okay. You, the lecturer week 1, week 2, I upload on UTS online already. Okay. Lecture week 1, week 2, and tutorial week 1 already. Okay. And similar for the lab. Okay. I will run parallels online and face to face. So it's up to you. You can attend to the lab or not. It depends on you. Yeah. If you can't attend, you can see it online. Okay. Or the recording will be uploaded on UTS online. Yeah. It's actually up to you because actually for the lab, the capacity of the lab, just only 5 or 6 students can attend to the lab. Yeah, because this is a very small room. Because attend to the lab, it's up to you. It's a drop-in. Drop-in is mean you can attend or not, or you can attend to online session. Yeah, online. I will run parallels. It's similar to this one. Yeah. Okay. So, oh my God. Okay, so we move to this question. Sound speed. Sound speed in the air and sound speed in the seawater. Okay, sound speed. Do you remember the equation to find sound speed? I showed you in the lecture slide yesterday. We have two different equations to find sound speed in the air and sound speed in the liquid. Okay, in the air, sound speed equal to actually I don't remember because we have already on UTS online, and you don't have to remember it. You can find it on here, learning materials. Okay.
Are we going to have that in exam? Is it like a formula sheet?
Actually, we don't have formula sheets, but all formula you can find in on the slide. Yeah. For example, for sound speed, okay, if you don't remember equation sound speed, you can find it here. Okay, this one. You have equation to find sound speed in gases. A equal to square root KRT. Okay, or in the liquid, you have sound speed equal to square root of elasticity divided by density. Okay, we have equation here. KRT for gases and E divided by density for liquid. Okay, so you have air equal to square root of K R T. Okay, and for liquid, sound speed equal to square root of elasticity divided by density. Okay, with the first one, as I said yesterday, K is specific heat ratio. And this one you have from the table. Okay, R is a gas constant from the table. And T is a temperature, but temperature in Kelvin scale, not Celsius. Okay, Kelvin scale. So one Kelvin scale equal to Celsius plus 273. Okay, you have to convert to Kelvin scale before any calculation in fluid mechanics. Okay, if you have temperature in Celsius, convert to Kelvin scale.
So you can add 273.
Yeah, adds 273 to Celsius. For example, now the temperature is 20 Celsius. It means 293 Kelvin.
Yeah.
Okay. So specific heat ratio and gas constant you have from the table. Table you can find in cost note on your test online. Okay, the cost note. Yeah. This one is the cost note on your test online for the air. Okay, you have got constant R will be equal to 286.9. Okay, or 287 joule per kilogram Kelvin. And specific heat ratio for air is 1.4. Okay, so depends on the temperature, you can find South speed in the air. Okay, for example, in this case, in this question, you have to find South speed in the air at sea level and standard condition, and at 8,500 meter altitudes. Okay, so you see that South speed in the air depends on KRT, but K is constant, R is constant. So South speed will depends on temperature. So to find the South speed at the sea level and 8,500 altitude, you have to find the temperature at sea level and temperature at 8,500 meter altitude. Okay. So the first question asks you find South speed in the air at sea level. Okay, will be equal to K R and temperature at sea level and standard condition. Okay, temperature at sea level and standard condition. Yeah, sea level is means 0 kilometer altitude. The temperature will be 15 Celsius. Okay, this one is standard condition. So in here, this one you have K is 1.4 from the table, R 287, and temperature is 15 plus 273, and you will have South speed. Okay. And similar for South speed at 8,500. To find South speed at 8,500 meter altitude, you have to find the temperature at 8,500 meter altitude. Temperature at 8,500 meter altitude. You can use this table. In this table, you see, you only have the temperature at 8 kilometer and 10 kilometer, not 8.5 kilometer. So in this case, interpolation. Okay, interpolation. So for example, at 8, let me see, the friend have a question. This table in the cost note you can download and you test online. Okay, this one I show you again one more time. Where to find the cost note? Okay, here is the cost note here. This one. Okay, the cost note here, this one. And you can download it and use in the quiz and the final exam and the lab reports and project. Okay, this one is very useful in case you don't have textbook. Okay, got it. Okay, now interpolation from the table at 8 kilometer. This one is altitude. This one is the temperature. Okay. At 8 kilometer, you have, let me see. At 8 kilometer, you have the temperature is 36.94. Okay. 36.94 Celsius negative. At 10 kilometer, you have the temperature here is 49.9. Okay, 49.9 minus 49.9 Celsius. Okay, so you have to find the temperature at 8.5 kilometer, you have to find temperature. Okay, so the interpolation will show you that 8.5 minus 8 divided by 10 minus 8 will be equal to t minus 36.94 divided by minus 49.9 minus 36.94. Okay, so from this one you can find the temperature at 8,500 meter altitude interpolation. Okay.
Isn't that just what the grain kind of looks like?
Yeah.
Yeah.
Yeah, it's look like. So you can find the temperature is 5,500 meter altitudes, and you apply to the south speed, you can have south speed at 8,500 meter altitude. Okay, and south speed depends on temperature. Okay, so you have the result here. This one will be is minus 40.2 Celsius negative. Okay, so if you have a look in the solution on UTS Online, tutorial 1. Okay, we have solution on UTS Online already. Yeah, this one south speed. Okay, and at 8,500 meter altitudes, is a solution. The temperature at 8,500 meter altitude is 40.2 Celsius. This one is correct or incorrect? 40.2. No. Yeah, it's negative. It's not positive. Because when we go up, temperature decrease. At the sea level, we have the temperature is 15. So 8,500, no. It's must be smaller than 15. And this one is negative 40.2, not 40.2. Okay. Yeah, this one is from the solution from is submitted by the study coordinator, and this one is incorrect here. This one is wrong. Yes, this one is wrong. I said this one is wrong. So you will have the different answer for this one. You can try to read by yourself, and you have the south speed at 8,500 meter altitude will be smaller than the sea level because the temperature is smaller. Okay, but the answer here is higher, so sure that is incorrect. Okay, so for in the end, you got it. In liquid, is a liquid. In the liquid, as I said, equation here, south speed equal to square root E divided by density. E is elasticity. And this question asks you find south speed in the seawater at 15 Celsius. Okay. South speed of seawater, A of seawater at 15 Celsius will be equal to E of seawater at 15 and density of seawater at 15. Okay. And how to find the properties of seawater at 15 Celsius? Use the cost note. Okay. Seawater. Remember that this one is seawater, not water. Okay. For seawater, the property of seawater is different with properties of air. Okay. For example, the density of seawater is 1030 kilogram meter cube. For water, it's 1000. Okay. So the density is 1030, and elasticity. Yeah, Buck modulus elasticity is the last one. Okay. The units at 15.6 or 15 is as okay. It's 2.34 times 10 power 9 to 34. Okay. So you will have this one here is 2.34 times 10 power 9. Okay. And the density of seawater is 1030 kilogram per meter cube. Okay. and you will have density of seawater is density in this case is subspeed 1507 meter per second. It's 5 times higher than subspeed in the air. Okay, it's a liquid for seawater 5 times higher. Is a in the air sea level we only have 340 meter per second. Okay, but in the seawater 1507 meter per second, 5 times, almost 5 times higher. Okay. Do you have any question about subspeed? No. Online student, do you have any question about subspeed? Okay, remember that we have two questions, two equations, two formula for subspeed. Is it gases and liquid? Okay. Okay. Next question. Actually, this let me see. You have one question. It costs not. Yeah. The last question here. Maximum diameters of a 5 centimeter long circular cylindrical steel needle with density is 8,000 kilogram per meter cube that can stay afloat on the water surface at 20 Celsius. Okay, and actually this question, we did this question on lecture already. Okay, just I only repeat it very quickly. For this question, we have a needle afloat on water surface. Okay, we have water. With density of steel is 8,000 kilogram per meter cube. Let me see. 8,000, yeah. It's 5 centimeter long. 5 centimeter long, and the temperature of water is 20 Celsius. This L is 5 centimeter, okay, and the temperature of water 20 Celsius, and you have to find the diameter D of this needle. So this needle can afloat on water surface. And why this one can afloat on water surface? And how many forces apply to this one? How many forces?
So if one because let's say,
Yeah. How many forces?
gravity.
Yeah. Gravity is weight of this needle, downward. And one upward force, in this case, we call it surface tension force, F, surface tension force. Okay. And this one afloat on water surface, it means we have surface tension force equal to weight. Okay.
Oh, okay. So is surface tension force in this case like the normal force?
It's a normal force. It's a force from the water applied to the needle. When we have an object afloat on water surface, we will have a force from water applied to the object. And this one is surface tension force. And surface tension force, we have equation is surface tension coefficient times the contact length. Contact length between the needle and water. This one is surface tension coefficient.
Is that a constant?
Depends on temperature. Surface tension coefficient. Okay, and this one from the table. And contact length. Contact length, when we see from the top view here, right here, the contact between the needle and the water surface will be is a rectangle. This one, you will have the contact. Okay, you have this one, it's needle. Okay, and you cut it on the water surface. You have you will have a rectangle. This one is L. This one is D. Okay, so the contact length will be L plus D plus L plus D, LD, LD, or 2L plus 2D. Okay, but usually, because this one is a needle, so D very small compared with L. So usually we can ignore D in this case. That's why we only have 2L in this case. Okay, because D very small compared with L. The diameter of this one is very small compared with the length. Okay. You can ignore it or you can keep it. It's up to you. But the answer is just a little bit different. Okay. But you can ignore in this guy.
You get the same mark?
The same or almost same. Actually, in fluid mechanics, the difference is smaller than 5%. It's very good. It means the difference between your answer and the answer is the answer sheet is 5%. It's very good.
But if it was something else that's not a needle, like a wooden plank,
You have to include everything. If, for example, it's not a needle, you have a flat plate like this. It's very complicated. Yeah, this one.
Yeah.
Okay, you have this one. If you have this one, the contact length will be is you have to include everything here, and here is a hole. Okay, so you have to include this one. This contact between the objects and water surface. So it will be equal to red one plus the blue one. Okay, all contact is this guy. Okay. So in this guy, you have T will be equal to surface tension coefficient times 2L. And surface tension coefficient, this one, you have from the table of water 20 Celsius, okay, 20 Celsius, surface tension coefficient here. At 20 Celsius, surface tension coefficient will be equal to 0.0728. Okay, 0.0728. Will be is 0.0728 Newton per meter.
but where did you find that?
On the table. Yeah, this one. It's a cost note. Okay, depends on the temperature, 20 Celsius. Yeah, 20. You have surface tension coefficient. Yeah, this one. Yeah, yeah, it's same. For example, at 18, yeah, you have to find by yourself. Yeah. Okay, so surface tension force you have width. Width. Do you remember equation to find width of the needle? Width equal to mg, mass times gravity. M equal to density times volume times z. Density times volume. Okay. With z, this one is 9.85. Sorry, 9.81. It's very common. Density of needle you have is 8,000 already. Okay. And the volume of the needle is volume of the cylinder. It will be equal to P d square over 4 times L. Okay, we have the needle. The volume of the needle is cylinder.
What's being multiplied by b squared? Is that pi?
Yeah. This one, which one?
The thing next to b squared, is that pi?
D square. Yeah, pi. Yeah, pi. Pi d square over 4 L. Okay. So because T tension force equal to the width, so you will have rho times P times pi times d square over 4 times L equal to sigma times 2 times L. Okay. This one, so in this equation, this one you have This one you have, this one you have, this one you have. So you can find D. You have to find the minimum diameter. Okay, so you have D from this one. Okay, and the answer here is we have D is 1.54 millimeter. Okay, so with this, if this needle have a diameter is smaller than 1.54, this one can float on water surface. Okay, the answer, okay, of this question. Maximum diameter of the 5 centimeter long circular cylinder, steel needle, that can stay afloat on water surface. Okay. Actually, this one we did this one on lecture yesterday. Yeah. Sorry.
So the second part of the question is that similarly for 10 centimeters.
Yeah, it's similar. It's similar for 10 centimeter long needle. It's you have to try. It's not double, you see, because the equation here is d square. Okay, you have to find here is d square. It's not double. You will have a different answer. Yeah, it's not double d. Yeah. And as a L, you see you have L. You can cancel out L here. So it's D will be equal to square root of 2 over density times pi over 4. Okay. So when the notice the same, almost same. It's the same. You see, because L is we can cancel out L here. Yeah. It's same. Yeah, it's same. Yeah, same as yeah, it's not depends on L. Okay. Okay. You based on this equation, rho 2L. Okay. It's a constant. Yeah. Do you have a question? This one, question 2, tutorial 1. Question 2, tutorial 1. No? Okay. So if you don't have any question, we move to our topic today is pressure variation. Pressure variation. Okay, pressure variation. Just summarize a little bit about pressure variation. Pressure variation. Okay, pressure variation is mean, for example, we at sea level, as Z is 0, and Z exists here, S, yeah. Okay, we will have dP over dZ equal to minus rho Z if we use Z direction. It means we go up, pressure decrease. Okay. Or if we use S direction, dP over ds equal to rho Z, because we go down, pressure increase. Okay, we go down, pressure increase. And if density is constant, it means, for example, for liquid, okay, we can assume that density is constant. Because liquid is incompressible substance. So the density you can assume as constant. For example, for water is 1000. Okay. So if density is constant, you will have Pz minus Po will be equal to minus rho Z with Pz here. This one is Po, this one is Ps. Okay. Or Ps minus Po equal to rho Z if density is constant. If density is not constant, you have to use this one. Okay. This one. If density is not constant. If density constant, you have to change to Pz equal to Po equal to minus rho Z, and Ps minus Po equal to rho Z. Okay. This one is pressure variation. We go up, pressure decrease, go down, pressure increase. And about pressure variation, we have some question in tutorial 2. Okay, we have tutorial 2. This one. Okay, we have this situation. We have 4 questions here. However, today we will try to finish question 1 and question 3. Okay, maybe question 2 and question 2 we will and 4 maybe 4, 2 and 4 next week. Okay, question 1. We start with the first one. Question 1. We have this system. For the situation shown, calculate the water level D. You have to find water level D. Inside the inverted container. Given manometer reading S is 0.7 meter and L is 12 meter. You find D. How to find D? How to find D? Based on pressure variation. We have this one, we call this one is point A. This one I call is point B. This one I call is point C. This one I call it point D. And this one I call is point E. Okay, so pressure variation in horizontal is constant, only change in vertical, in Z or S direction. Okay, in horizontal is constant. For example, you are here or you're at the central station, pressure constant. It's not changed. Yeah, and you see if you based on the equation, yeah, pressure variation depends on density. Okay, that's why in the air, you're at the ground level or level 10, you can't feel anything. You can't feel pressure change because the density of air is very small. So the pressure change in the air is very small. Okay, in the air, if the change in the height is smaller than 100 meter, you can assume a constant. Okay, for example, in the ground level, or actually senior tower constant, the same. But in water, because the density of water is 1,000 kilogram per meter cube, so you only swim down only 1 or 2 meter, you feel pressure change. Okay, you go swimming, you go down to 1 or 2 meter, you can feel it. Okay, because the density is 1,000. 1,000 kilogram meter cube is mean is 800 times higher than in the air. It means when you move 1 meter on the water, it's similar to when you move 800 meter in the air. Okay, pressure different because the density. Okay, the density of water is 800 times higher than air. Okay, so in the air you can assume a pressure constant. Okay, it's a normal condition. If the different only few meter or maybe smaller than 100 meter. Okay, so in this case, you find D. You find D. You have to find D. Okay, D. Because pressure variation show you that pressure different between 2 points. Okay, and if you know the distance between 2 points, so if you know pressure between 2 points, you can find the distance. Because, for example, you want to find D, you can find D if you know pressure B and pressure C. Because you will have between B and C, you will have PB minus PC equal to rho D. Yeah. I'm sorry, rho ZS. Sorry, here is I forgot Z here, and I forgot S here. Rho ZS on rho ZS. So sorry. Rho DZ. Okay, rho ZD. Okay, the distance between point B and point C, PB minus PC will be equal to rho ZD. Okay, the equation. So to find D, you have to know PB and PC. And to find PB,
Isn't PC and PD pressure?
yeah, P pressure.
So how would knowing the pressure give us this? Oh, okay.
Because pressure depends on the distance.
Yeah.
Yeah. Pressure difference between 2 points based on the distance between 2 points. Okay. So PB, how to find PB? How to find PB? Formula, but based on which point? You have to find PB, and you know the distance between B and A. So you can find PB if you know PI.
What is A? Is A like ground?
A is a water surface. Water surface. Water surface, yeah.
So A is water.
Yeah,
Like
water
all of-
surface.
All of that thing's underwater.
B and C is under the water. A is water surface.
Like there's a pocket of air.
Yeah. And in here is air. We have air.
Okay.
Or atmospheric pressure. It's 101.3 kilopascal. It's absolute pressure of atmosphere. Or if you use gauge pressure, it's 0 gauge, 0 kilopascal. It depends on you use absolute or gauge pressure. Okay, because gauge pressure is a pressure different between absolute pressure and ambient pressure. So for ambient, the difference between ambient and ambient is 0. So gauge pressure of ambient is 0. Okay. Yeah. I show you here to more understand about pre-coil pressure. You can have a look in the slide in lecture 1. Okay, have a look at it again. We have this one. Pressure, we have absolute pressure, gauge pressure, and barometric pressure or ambient pressure. Okay. Gauge pressure is from this pressure sensor here. So pressure difference between absolute pressure of air inside this tank and ambient pressure. Okay. So this one show you gauge pressure. Gauge pressure will be equal to absolute inside the tank minus ambient outside. Okay. So for the ambient, if inside this tank is ambient and outside is ambient, we will have gauge pressure of ambient is 0. Okay. So gauge pressure of ambient is 0. Absolute pressure of ambient is 101.3 kPa at sea level. Okay. Oh, sorry. Okay. So you can find PB if you know PI. And PI, pressure at the water surface will be equal to atmospheric pressure. Atmospheric pressure. Okay. And atmospheric pressure, you can use 101.3 kPa absolute or 0 gauge. It's up to you. The result is same. Okay. PC, how to find PC? PC. How to find PC? Between C and D is air. And so pressure is the air. The pressure change in the air is very small. Which means pressure difference between C and D is very small. C is the water surface. D is mercury surface. But all of them equal to, you will have, this one is inside. For example, PO is pressure inside this container. So PC will be equal to PO, and PO equal to PD. Okay, pressure on the surface equal to atmospheric pressure, and atmospheric pressure inside this container. Okay, so PC will be equal to PO. PO is pressure inside the container, and pressure inside the container equal to PD. Okay, what mercury surface. So PC you can find if you know PD. Okay, PD. And PD, because you know the distance between D and E, so you can find PD if you know PE. Okay, because distance between D and E is 0.7 meter. And PE, mercury surface, will be equal to atmospheric pressure is 101.3 kPa absolute or 0 kPa gauge pressure. Okay, this one is process how to find the distance D. Okay, so now we will start with the 5 PA. So we have to find PA. When you have PA, we have 5 PB. Okay, 5 PE, have PE, 5 PD, have PD, 5 PC, and after that we will have D. Okay. So in this case, you can use atmospheric pressure is 0 or 101.3. It's up to you. But I will use 0 gauge pressure, easy for calculation. Okay. So we have atmospheric pressure already, and PA will be equal to atmospheric pressure 0 gauge, 0 kPa. Okay, we said that we use gauge pressure already. PA if on the water surface equal to atmospheric pressure. When we have PA, 5 PB. Okay, PB because B below A, so PB will be higher than PA. PB minus PA equal to rho Z, and the distance between B and A is L, rho Z L. Okay. Rho is the density. This one is rho of water because between A and B we have water. Okay. So rho of water here is 1,000 kilogram meter cube. Z is 9.61. L here is 12 meter. PA 0. So from this one you have PB. Okay. So PA you have atmospheric pressure you have, PA you have, PB you have. Okay. Now the second line. PE, mercury surface, will be equal to atmospheric pressure. PE equal to atmospheric pressure or 0 kPa, gauge pressure. When you use gauge pressure, other pressure is gauge pressure, not absolute. Okay. PE 0 gauge. This one you have from PE you find PD. This you have the distance between D and E is 0.7 meter, and you have D below E. Okay, so you will have PD minus PE equal to rho Z H, rho Z H. But remember that between D and E we have mercury here, this one. So the density here, the density is this equation, is density of mercury, not water. Okay, because between D and E is mercury. So the density of mercury we have from the table. Yeah, mercury density 13,600 kilogram meter cube. So be careful if you use density of water in this case, it's wrong. Okay, this one is between D and E, we have mercury. Yeah. This one is 13600 kilogram meter cube. This is 9.81, and S here is let me see, 0.7. Okay, PE is 0, so you can find PD. Okay, and PD equal to PC because equal to PO is a pressure inside the container. Okay, so you have PC equal to PD. PC you have, PD you have, PC you have. Okay, now based on this equation to find the distance between B and C. Okay, the distance between B and C, you will have PB minus PC equal to rho Z D, and between B and C is water, and B below C. Okay, B below C, so PB minus PC equal to rho of water ZD, and you will have D equal to PB minus PC over rho of water Z. With PB you got it here. Okay, PC here, rho of water is 1000. This is 9.81. Okay, so from here you can find D, the distance. The distance between point B and point C. Okay. Do you have any question? Any question? Online student, do you have any question? Pressure variation. No? Okay. Actually, yesterday I give you an MCQ question. This one about pressure variation. Do you have the answer for this one? MCQ. How about question 1 for the MCQ question I gave you yesterday? Pressure C. Pressure C. It's gauge pressure. It's 50, 60, 40, or none of the above. This one will be similar to the quiz. Okay, quiz 1 will be week 6 before Christmas and New Year. Okay. So please give me the answer for question 1. A, B, C, or D. You choose A, B, C, or D. This question I gave you yesterday. Anyone have the answer for this question? A? Yeah. You have A? 1A. 1. You guess it or you did it? Guess? Okay. 50,000, 60,000, and 40,000 is very close. You have to find it before you me the answer. Okay. Online student, anyone have the answer for this question? D, 1D. Okay, 1A and 1D. Anyone have answer for this question? Anyone have? There are 50 kilopascal, 60 kilopascal, and 40 kilopascal. Anyone have answer for this question? Gauge pressure, not absolute pressure. Gauge pressure is a pressure difference between gauge pressure will be equal to absolute pressure minus ambient pressure minus 101.3. Okay. So if we assume we assume as ambient pressure, we are living in zero gauge, zero pressure is zero. So we will have gauge pressure for other instrument. Okay. Anyone have answer for this question? Okay, as I said, this one is very similar to the quiz. Okay, you have MCQ on the quiz. Quiz is week 6. You only have maybe three weeks. Okay, so please try to do it by yourself. Give me the answer. I will give you 5 minutes to do this one. 5 minutes. Yeah, 5 minutes to do this one. Yeah, in week 6, right before the Christmas and New Year. I don't remember. 22 or 23 on the lecture times. Okay, you have this system.
What, is it gonna be during the tutorial time?
No, lecture time, during the lecture time on Monday. On Monday from 1 to 3 p.m.
How long is it for?
80 minutes. Yeah, the quiz will be in 80 minutes, and
We have to get out to log in.
yeah, you have to log in using the UTS account. Can you see? Let me see. So using the subject outline. Not, yeah, so not group activity. This one is individual. Yeah, quiz held during the lecture. Okay, in 21st, right before the Christmas, last week before Christmas. Okay, on Monday, and the quiz topic here. I will talk about the quiz topic later, because at this moment we only this one is week 2. Okay, I will give you 5 minutes to finish question 1. Okay, and give me the answer. The question I sent you yesterday already. Pressure C. Yeah, this one is C. C. C here. Okay, pressure C. Gauge pressure. Not absolute. It's 50. 50 in this case is gauge pressure inside of air is this time. This one. 50 kilopascal is gauge pressure. Yeah. It's going to be equal to absolute pressure minus ambient pressure. Yeah, you can. If ambient is 0 gauge. Yeah, 50,000. Yeah, pressure in this area is 50,000. No, if you assume as outside is 0 gauge, so this one is 50,000 only. Okay, if outside is 101.3 kPa, pressure here is 101.3 plus 50 kilopascal, absolute pressure. Okay. Give me the answer, online student. A, B, C, or D? Which one you choose in this case? A, B, C, or D? Actually, for MCQ question, if you don't know the answer, you have 25%. Yeah, multiple choice online.
Even the final exam?
Yeah, even final exam.
All the questions.
All question. All question, multiple choice.
Very good.
This one is similar to what we did in question 1 tutorial 2. Okay, it's similar. What you did question 1 tutorial 2.
So do you minus the 50,000?
This one is 50,000 Pascal.
And then that's pushing on the water. Right?
This one. We have water in the tank.
Yeah.
And 50 kilopascal is pressure of air pressure. It's not water pressure. Air pressure on the top of the tank. Okay.
So in between C, that's also air.
Between C, I will see. So you, for example, I call here. This one is CE. For example, this one is A. This one is B. This one is C. Okay. This one is E. This one is D. Okay. A, B, C, D, E.
Right. Between C and B, that's air.
Yeah, between C and B is air.
So would it be the same as?
Yeah, pressure C is the same with pressure B.
Okay. And the pressure of B is 50,000, right?
Pressure B,
Yeah.
50,000 now.
Right.
Pressure A is 50,000.
Right. Okay. So what's the formula for that?
Between A and B.
Yes.
Between B and B, A below B. So PA minus BD is equal to rho Z. And distance between B and A.
Okay. Yeah. I get it.
Got it?
Yeah. So it'd be less than 50,000?
Yeah, see, we have two.
Less than 50,000,
Yeah, it's less than 50,000.
yeah. Okay. Could be C or D.
Yeah, could be C or D. Yeah, so you have 50%. Two, we have two. Student choose, and the answer is C. 1A, 1D, and 2C. Okay. So, yeah, I say C is correct answer. C. This one. Correct answer is C. Okay. Because in this case, you have to find pressure C. Okay. And you press to find pressure C, you have to know pressure B. Okay. To know pressure B, you have to find pressure A, and pressure A equal to 50 kilopascal, or equal to air pressure inside the tank. Okay. So you will have PA equal to 50 kPa. Okay. And this one is gauge pressure. Gauge pressure already. Okay. Because this one is from the pressure sensor here. It's been presumed from this pressure, you have gauge pressure.
And A is negative.
Air
Yes.
at 50 and outside is 0. Air outside, here, outside we have P outside, atmospheric pressure is 0 gauge.
Right. Is
Oh,
B
sorry.
also 0?
Now on B not 0.
B, yeah.
Here pressure in here, pressure inside
Yeah.
is 50 kPa.
Right. Yeah.
Okay. Air outside is 0 gauge.
Okay. Yeah.
So pressure A is 50 kPa. From A, you find pressure B. Okay, PA minus PB equal to rho Z. And distance between A and B is 1 meter. PA minus PB because A below B. Okay, A below B. So you will have PB equal to PA minus rho Z 1.
Is it at the same level?
Same level.
Or it's
At the same level,
it's the same?
the same pressure.
Yeah.
Same pressure, yeah.
Either.
Either, yeah, the same. Same level, same pressure. So this one we have, this one is 50. Okay. 50 kPa. The density here is 1000. 50 kPa, so you have to convert to Pascal. 50,000 Pascal. 1000 kilogram meter cube SI unit. Z is 9.1. Okay, so this one is approximately 40,000 Pascal. Okay. So PB equal to PC. Yeah, so you have PC equal to PB and approximately 40,000 Pascal. Okay, so the answer is C. Okay, similar question 2. Give me the answer A, B, C, or D. You have 5 minutes. Yeah, you have, yeah, E here, this one. It's similar to this one. Bottom, yeah. Actually, I will upload the recording on UTS Online. So you can have a look at the recording of the online session on UTS Online. B. Okay, we have one answer, it's B. One student give me the answer B. Okay. C. B below C. So pressure B higher than pressure C. Sorry, E. Sorry, E below C. So pressure E higher than pressure C. C is 40,000. Yeah, PE minus PC equal to rho Z, the distance between E and C.
Okay, so it's going to be less than 40,000.
So it's so press no greater, higher. So maybe B or C or D. B or C or D. Okay. So which one is the answer? Which one is the answer? One student choose B. Okay. And another one choose B. Okay, we have two B. So maybe B is correct answer. Okay. B. Yeah, B is correct answer. So you have the distance between C and D is 0.5. Okay. The distance between D and E is 1 meter. So the distance between C and E is 0.5 meter. Okay. 1 minus 0.5. So the distance between E and C is 0.5 meter. The distance between E and C. Okay. Because E and D is 1 meter. C and D is 0.5 meter. Okay. So between E and C is 0.5. 0.5 is 1. Okay. So you will have PE minus PC equal to rho Z 0.5. Rho Z, the distance between E and C. So PE will be equal to PC plus rho Z 0.5. And PC we have is 40,000. The density of water is 1,000. This is 9.1. 45,000 Pascal. And the answer is B. Is correct. D. None of the above.
Yeah, so they're both precise.
Actually, in 5%. Yeah, 5%. the difference is smaller than 5%. It's good. Actually, it's smaller than 10% is accepted. Accepted
Did
is,
you get full marks?
yeah, full mark, still full mark.
What was the answer that the working out yet?
You only give the answer. I don't know what you do, but you give me the answer. Multiple choice.
Oh,
Okay.
Every question is multiple choice.
Yeah, all question is multiple choice. You don't have to show me what you do. You only show me the answer.
No, I was saying down there, if you go down to what answer did it give? So,
You do 9.8 something thousand.
yeah.
It's approximately 45,000. Okay, maybe it's, you have 46,000 or 47,000. You choose 45. Okay, because smaller than 5%. Yeah, smaller than 5%. Actually, you have at least you have 25%. Correct.
Yeah.
You have only 4 options.
And
40.
no, it's not aimed for 30.
Yeah, no more. You have more than 30%. Okay, it's not. Yeah, it's a little easy. And you see, and actually, as I said, you have sample, yeah, sample quiz. Sample quiz.
It's the hard part,
It's not too hard, I think.
because a lot of people say it's very hard.
Yeah. Here is sample. Yeah, you see, sample.
I saw the final paper, it was very hard.
It's final exam.
Yeah.
One of them is the thing, but
It's final exam. The final exam 2 hours.
You already did it. I don't know.
This one is final exam. It's a sample final exam. Yeah.
If I saw that, I would
Mhm. In the quiz, you will 80 minutes, so you will have around 10 questions. Final exam 2 hours, 15 questions. Yeah. Okay, and you see we have sample. Yeah.
you get like an HD or something.
I don't know. Actually, I don't know. Actually, I don't know. Yeah, yeah, you have 15. So I will say about the quiz and final exam later because this one is week 2 only. Okay. So do you have any question about this one? Maybe we will still have 3 more questions on tutorial 2, but we will leave next week. We can do it next week.
Was there an actual last week? Or
Sorry.
this week, the first lecture?
Last week is the first.
So the first lecture?
Last week. This week is the second one. Second week. Week 2. Okay. Everything you have on UTS Online, you see, a recording. And the recording of tutorial today, I will upload on UTS Online tomorrow. Okay. Online student, do you have any question for me? No? Okay, if you don't have any question, thank you and see you next week. Yeah, thank you. Yeah, the tutorial is only 1 hour and 30 minutes, not 2 hours as so in yeah. It's similar to last semester. Do you remember it? Last semester tutorial only 1 hour and 30 minutes. Yeah, not 2 hours. Okay. Okay, thank you. See you next week.
What was your name?
My name is Khao.
Cal?
Yeah, Khao.
Cal?
Sorry? Khao CAO. Oh, my name you can see in UTS Online. Here. Here's my name. You see in subject and my email. If you have any question, you can email me. Okay, it's yeah, it's me. It's me.
Thank you very much.
Yeah, thank you.
No, our voice is gonna be in the recording.
Yeah. And actually, for the lecturer, not only the recording, the recording of last semester uploaded on UTS Online already. everything. You see, if you have looked in UTS Online, learning materials. As I said, this one is, I will upload the recording of tutorial and lecture on here. And for example, for week 1, okay, week 1, introduction of fluid properties, and you have lecture slide here, recording video here. Okay, this one is a recording of subject coordinator on UTS Online. Okay. Okay, everything you can find on UTS Online. And if you have any question, you can email me. Thank you. See you.
How many people are in this class?
14 online.
14.
Yeah, 14 online.
So, I mean, 16 in the whole subject.
No, around 30, more than 30. More than 30.
Ah, so they're not going to
Yeah, some of them just only see the recording, not 10 to anything. Okay. Thank you.